Today we have some power supplies here. We have some toroid and AI core transformer and some switch mode power supplies. We're going to compare its ripple with 1 ampere to 5 amperes load. This toroid here is connected to this bank of capacitors. These are 22,000 UF. Four of them in parallel. There's 4 of them in parallel. We also have this power supply. It's 10,000 UF. 4 of them. So to 10,000 UF per rail, about 20,000 UF per rail. We also have this power supply. It's 15,000 UF. There's 6 of them. So about 3 capacitors per rail. First, we have this transformer base AI core attached to this power supply for 10,000 UF. So that's the output of the power supply. 50 volts. This is our no load ripple. Around 4.72 millivolt. You can see it here. We're gonna turn on the power supply and set it to 1 amp load. It's already set to 1 ampere. Turn it on. I said that's 1 ampere load. How much did the voltage drop? That's around 53. Drop around 7 volts. Okay, so these are 1 ampere ripple. So these are ripple. It's around 448 millivolt. That is 1 ampere load. You can see it here, ampere. 1. See, the ripple is pretty clean. There's no ringing or noise on the on the wave. We're going to compare it later with the switch mode power supplies. Now we're gonna set it to 2 amperes. First, we're gonna record the ripple around 444 millivolt. Now I've set the electronic load to 2 amperes. 2 amperes load. Voltage drop to 42.5. Okay, 2 amperes load. And our ripple is it's now 796. Okay, that's about 800 millivolt up to ampere. Alright, 3 amperes. Voltage has dropped to 39 volts. Ripple for 3 amperes. 1.12 volt. Okay, this is a 4 amperes load. And our ripple 1.37. Okay, so that's our ripple. Now 5 amperes load. Voltage has dropped to 32.4. And our ripple for 5 amperes. Ripple 1. Around 1.6 maximum. 1.56, 1.58. Just it all to 1.58 millivolts. Now we're done with this power supply. Now we're gonna move to this 15,000 UF power supply with 15,000 UF capacitors, 6 of them, 3 each rail. This power supply has a built-in fuse here, so at higher current load there will be a voltage drop in here, maybe 100 millivolt or something. This one, it also has a built-in fuse, but I have shorted this one. As you can see, there's a jumper here. This power supply is capped out. So this is our no load ripple around 2 millivolt, 2.8, 2.7. One ampere load. Okay, it's set to 1 ampere. Okay, so that's 1 ampere load. So that's our ripple. 196, 198. Settle to 196 millivolt. So compared to the 10,000 UF, 4 of them, 20,000 per rail. This is the ripple at 1 ampere with 15,000 UF, 3 per rail, 45,000 UF per rail. The ripple is 196 millivolt. That's almost less than half. Now let's go to 2 ampere. Okay, so that's 2 ampere. 2 ampere ripple. 350 millivolt. and it's around 5.6, and it's settled for 356 millivolt. 356 millivolt. It's 3 amperes. Set it to 3 amperes. 3 amperes, 3 amperes. Okay, that's the ripple. 492 millivolt. So that's our ripple. Now let's go to 4 amps. 4 amp next. $600 millivolt. That's a very nice ripple compared to just 20,000 UF. It's less than half. Now to 5 amperes load. 5. Now it's 5 amperes. 5 amperes. Now a ripple 700 millivolt. Measure the ripple of this toroid with 422,000 UF capacitors. The toroid with the 422,000 UF capacitor is now connected. So that's our no load ripple. Now we're gonna proceed with 1 ampere. So 1 ampere. Let's check our ripple. So that's our ripple around 100 millivolt, 106, 107. Let's just settle for 106. Let's just settle for 106 millivolt. Let's go to 2 amperes. 2 amperes. It's 2 amperes. Now set to 2 amperes. So that's our ripple around 200 millivolt, 204. Amperes. Let's go to 3 amperes. 3 amperes. $288 millivolt. Okay. 4 amperes. Ito mga set to 4 amperes. $370, $372. 0.72 ng to 5 amperes. 5 amperes. Core Toroid 144. So this is our result. This with 20,000 UF rail. This is 45,000 per rail. This is the last one, that one for 22,000 UF in parallel, so around 88,000 UF. So as you can see, the ripple with 20,000 is 444, almost half with 45,000 UF, and that's around 90 millivolt less with 88,000. So at 5 ampere 1.58 with just 20,000 UF, almost less than half with 45,000, and a little bit lesser with 88,000, just 448 millivolt. So how much is that? So the difference between these two is 252 millivolt. So now let's check some switch mode power supply. This one, this is a symmetrical plus or minus 65 volts power supply. The switch mode plus symmetrical plus or minus 65 volts power supply is now connected to the electronic load, and we have 1 ampere load, 1 ampere here, around 65 watts load on its rail. And this is our ripple. It's running around 560 millivolt to around 600 millivolt, 630 millivolt, 624. So ripple is around 560 millivolt minimum, and it jumps up to around 630 millivolts. So the ripple with 1 ampere load is around 560 to 630 millivolt. Now I'm gonna set this to 2 amperes. 2 amperes, 2 amperes. Right, so set to 2 amperes. Let's check our ripple. The max I have seen is around 640 millivolt. Max 640 millivolt. Times So the minimum is about the same. I think the minimum I've seen 576. And minimum is about 576. $640. So the max I've seen is about 640 millivolt. 640. So the ripple from 1 ampere to 2 ampere is a little bit of change, little bit higher, minimum of 576 or around 16 millivolt difference. The maximum is around 640 millivolt. 2 to 3 amperes. Okay, 3 amperes. Let's check our ripple. Looks like the ripple actually decrease with higher load. 584. So the max I've seen is around 584 millivolts. So that's 600 millivolt. The peak I've seen around 600 millivolts. So let's put 600 millivolt for maximum. So the minimum ripple actually become lower a bit. That's 456 millivolt. Or about 456 millivolt the minimum. So this is our ripple. The ripple actually becomes lower with higher load. Let's see if let's check 4 amperes. Okay, that's 4 amperes. That's our ripple. 624 maximum. So that's 630. So I think the maximum ripple I have seen is around 630 millivolt around at the start. So that's 624. 630 millivolt maximum ripple. Wow, that power supply turned off with just 4 amperes load. What happened there? Did it die? Okay, so looks like the power supply died. So we're gonna skip this one. We're gonna move on to the next power supply. Next, we have this cheap $10 switch mode power supply. It's currently set to 50 volts, and that is our low load ripple, about 30 millivolt. Okay, 1 amp, 1 ampere. That is our ripple, about 70 millivolt. Seventy-four millivolt max. Okay, 1 ampere, 74 millivolt. Okay, that is 1 ampere, 74 millivolt, 2 amperes, 2 amperes, that's 2 amperes. $90, $95, $96, $97, about 97 millivolt max. 97, 3 amperes. Let's go to 3 amperes. 2 amps. So that's 3 amp. So that's our repo 120 millivolts, 124, 126, 128. So the max I've seen around 128 millivolt, 128 at 3 amperes. Okay, so that's 128 at 3 amperes. Let's move to 4 amperes. That's 4 amperes, 200 watts. $150 millivolt, 156. So around 156 millivolt max. 56. That's 156 millivolt at 4 amperes. 5 amperes, 250 watts. By the way, that's 250 watts load, and it's pulling around 284 watts. 284 to 85, so it's wasting about 35 watts power. Okay, so that's ripple 184. So looks like the max ripple is around 184 millivolt. So that's our ripple for this cheap $10 PSU. I think that's not very bad. 184 millivolts at 5 amperes, and this one can do 8 amperes. Let's see what is the ripple at 8 amperes. $400 watts. Is our ripple 262 millivolt, 266. Top 74. 76. So that's our maximum ripple, 276 millivolt. Okay, so this is our ripple for 8 amperes, 276 millivolt. By the way, the ripple is a bit lower compared to when I measured it last time, because I changed one of the capacitors inside. I will show it later. Okay, so this is the capacitor that I have replaced here. This is an original capacitor. This 1000 UF. Originally there's 3 of them, 1000 UF, but then I've replaced this one. I've replaced it with, see, that's 1000 there, 1000 UF. There's 3 of them originally, but I replaced the one with 2200 UF. Okay, that's 2200 UF. At first I changed all of them with 2200, but I found out that if there's too much capacitance on the output, the power supply would not turn on. The 2200 UF is fine, but with the added capacitance from the load, the power supply sometimes would not turn on. So I removed the other 2200 and I returned this 1000 UF, and I just left this one 2200 UF. Next we have this switch mode power supply. It's 68 volts power supply. So we're gonna measure the ripple of this power supply from 1 ampere to 5 amperes. This from Ruding Tech. Okay, the power supply is hooked up now to our electronic load. It's pulling around 4 watts without any load. So the power supply is wasting 4 watts while it's standing idle. This power supply has a nice temperature controlled fan. So you can see it's not running without any load. Okay, that's 1 ampere load. Let's check its ripple. Okay, so that is the ripple without any load. Now let's put some 1 ampere load. Okay, so that's 1 ampere load. Let's go check the ripple. So that's the ripple. 154, 56, 158, 162. 162 we just 162. Okay, so that's 162 millivolt with 1 ampere load. Now 2 amperes. Okay, that's 2 amperes load. So that's our ripple. 194 millivolt, 94, 196, 204 millivolts. So I guess that's the max, 204 millivolts. Okay, so that's 2 amperes, 3 amperes. Okay, so that's 3 amperes. Oh, that's 306 millivolt, 308, 310. Okay, looks like that's the max, 310 millivolt. Millivolt. Okay, so that's 310 millivolt at 3 amperes. I'm going to 4 amp, 4 amperes. Okay, so that's our ripple, 400 millivolt, 428. am seeing 428 millivolt. It's the 432. Did I see 432 there? 432 millivolts. I think the maximum I seen this I have seen is 432 millivolt. 432. Okay, so that's the maximum. 432 millivolt. Okay, so that's 432 millivolt at 4 amperes. I'm gonna do 5 amperes. Okay, so that's 5 amps. 552 millivolt, 572 millivolt, 572, 584, 592, 'Okay, I think that's the maximum, 592 millivolt. 592 millivolt. So that's the maximum of 5 amperes, 592 millivolt, peak to peak. I could not hear the fan of the power supply if it is working, because the fan of the electronic load is pretty loud. Okay, that's the I'm going to point the mic on the fan. Not hear the fan if it's working or not. I think the fan is not activating. So the electronic load is pulling around 340 watts, and the fan of the power supply is not activating. So I think 340 watts is too low for it, or it is not hot enough for its fan to activate. Okay, that's it for today's guys. Please subscribe to the channel. See you next time.